All right, strap yourselves in for a deep dive into the moon.
The moon, huh?
Yeah. You know, I know you're fascinated by it. And I found this awesome guide to the moon.
Oh, cool.
It's amazing, so we're going to use that today.
Yeah.
We're going to uncover some pretty mind-blowing facts, I think. Get ready to have your mind expanded.
I'm ready.
Okay.
My mind is wide open.
Awesome.
Right.
So let's just jump right in. Okay. So
Yeah.
when you look up at the moon, you're seeing something that's been around for like 4.5 billion years.
That is a long time.
A long time.
Yeah.
And scientists believe it was formed from debris after a Mars-sized object collided with Earth.
Whoa, whoa, whoa. Isn't that crazy? Mars size.
Yeah,
That's
it's huge. It's kind of blown my mind. Like,
yeah, like how did
that even happen?
Right. How did that not obliterate everything?
Right. And like, did that set the stage for life as we know it? I don't know. It's amazing.
Yeah, that's a question that a lot of scientists are still trying to figure out, you know?
Yeah.
Like what were the conditions that allowed for life to form after such a cataclysmic event?
Right.
But I think before we get ahead of ourselves too much, we should probably talk about something that people see every night.
Okay.
The moon's phases.
Oh, yeah. Okay.
You've probably noticed how it seems to change shape throughout the month.
Oh, absolutely. I love watching the moon. You know when it's that little sliver of a crescent and then it grows into this big, round, full moon? I never get tired of it. But you know what? I got to admit, I'm not really sure about the science behind it.
Well, it's not that the moon itself is actually changing shape. It's more about how the sunlight is reflecting off its surface as it goes around the Earth. Imagine you have like a ball and a flashlight.
Okay.
If you shine that flashlight on the ball, you're only going to see the part that's lit up, right?
Right.
It's the same thing with the moon and the sun.
Oh, okay.
The sun's like the flashlight.
Got it. So as the moon moves, we're basically seeing different, like, perspectives of its sunlit surface, creating those phases.
Exactly. And each of those phases, you know, they all have their own special significance. Like the full moon, for example.
Okay, full moon, yeah.
People associate that with everything from, you know, heightened emotions to werewolves.
Werewolves, huh? I might have to stay inside during the full moon, just in case. But speaking of the full moon, have you ever noticed that it looks so much bigger when it's near the horizon?
Oh, yeah, that's the famous moon illusion.
Moon illusion, okay.
It's a trick that our brains play on us because even though the moon is the same size wherever it is in the sky,
Right.
when it's near the horizon, it's near things that we're familiar with, like trees and buildings. So our brain compares it to those things and makes it look bigger.
Oh, it's trying to, like, make sense of it.
Yeah, exactly.
Okay. That's so interesting. Okay, now, for a question that has bugged me for, like, my entire life, why do we only see one side of the moon? Is the moon, like, intentionally hiding something from us? What's going on?
Well, not exactly hiding something. It's more that the moon is tidally locked to the Earth.
Tidally locked.
It means
okay.
it rotates on its axis at the same rate that it orbits our planet. So think about it like a dancer who's always facing their partner while they're moving in a circle.
Ah, got it. So
Yeah.
it's like a perfectly synchronized cosmic dance.
Exactly.
Okay. But does that mean that there's a dark side of the moon?
Ooh, good question. That's actually a misconception.
It is.
Yeah. All sides of the moon actually get sunlight,
Okay.
but we only ever see the one face because of that tidal locking.
So there's no, like, secret alien bases on the other side?
Not that we know of.
Okay, good. Good to know. So this tidal locking
Yeah,
has some pretty interesting consequences.
it does.
Not just for the moon, but for Earth as well.
Yeah.
Like, how does the moon influence our tides?
Oh, the tides. Okay, so imagine the moon's gravity as like an invisible hand that's pulling on the Earth. And this pull creates these bulges in the ocean.
Bulges.
Yeah, one bulge on the side that's facing the moon,
Okay.
and then another bulge on the opposite side of the Earth.
Wait, why a bulge on the opposite side?
That's because of inertia.
Okay.
Think about when you swing a bucket of water in a circle.
Yeah.
The water tries to like fly away from the center of that circle.
Right.
And it's kind of the same thing with the Earth.
So those bulges are the high tides.
Exactly.
Okay.
And as the Earth rotates, different parts of the planet are passing through those bulges,
Yeah.
which gives us 2 high tides and 2 low tides every single day.
Right.
But it's not just the moon that's playing a role in this. The sun's gravity is also kind of involved. You know, it creates this cosmic tug of war.
A cosmic tug of war. Okay. I need you to explain this.
So when the sun, the Earth, and the moon are all lined up,
Yeah.
their gravitational forces combine to make these extra strong tides.
Okay.
And we call those spring tides.
Spring tides.
Yeah.
Okay.
And we see those during a new moon and a full moon.
Okay.
But then when the sun and the moon are at right angles to each other,
Yeah.
their gravitational forces kind of cancel each other out a little bit.
Right.
And then we get these weaker tides called neap tides.
Reed tides. Okay. So it's like a cosmic dance.
It is a cosmic dance.
Okay. The moon and sun are taking turns leading. This whole, like, interplay of gravity is amazing.
Yeah. And this interplay is also what causes those amazing events, solar and lunar eclipses.
Oh, eclipses, yeah.
Which happen because the sun, earth, and moon are lined up in a very specific way.
I've always been fascinated by eclipses. They feel so, like, mystical, you know?
They are really awe-inspiring, yeah. So a solar eclipse happens during a new moon, when the moon passes directly between the sun and the earth.
Right.
And depending on how perfectly they line up, it can be total, partial, or annular.
Annular, okay.
It's the Ring of Fire.
Oh, the Ring of Fire.
Yeah.
I've only ever seen a partial solar eclipse.
Well, during a total solar eclipse, the sky actually goes dark, temperatures drop,
Wow.
and if you're in the path of totality, you can see the sun's corona.
Oh, that sounds amazing. That's definitely going on my bucket list.
It's incredible. What about lunar eclipses?
Oh, yeah. Those are the ones where the moon turns red.
Yes. Okay.
So lunar eclipses happen during a full moon when the Earth passes directly between the sun and the moon, and it casts its shadow on the moon's surface.
Ah.
And that red color you mentioned, it's because of something called Rayleigh scattering.
Rayleigh scattering. Okay, what is that?
It sounds complicated, but it's pretty simple. Basically, when sunlight passes through the Earth's atmosphere, the shorter blue wavelengths of light get scattered away,
Okay.
and that leaves the longer red and orange wavelengths
Right.
reach the moon.
Oh, so it's like a sunset being projected onto the moon.
Exactly.
That's so cool. Okay, but I have another question. If the moon is constantly being pulled toward Earth by gravity, why doesn't it just crash into us? That is an excellent question, and it really gets to how orbits actually work.
Okay.
So the moon is constantly falling towards the Earth,
Okay.
but it also has this forward momentum, this
Yeah.
sideways motion that keeps it orbiting. Imagine like a ball on a string,
Okay, yeah.
and you're swinging it in a circle. The string's pulling the ball inwards, just like gravity's pulling on the moon.
Right.
But the ball's forward motion keeps it moving in a circle.
Okay. So it's forever falling, but also forever moving forward.
Yeah.
That's amazing.
It creates that perfect balance.
It's like poetic almost.
It is, and that's the same principle that governs satellites and even the International Space Station.
Wow. Okay, that's mind-blowing.
It really is.
Okay, so I read somewhere that the moon is moving away from Earth. Is that true?
It is true. It's happening very, very slowly, though.
Okay.
About 3.8 centimeters or 1.5 inches every year.
1.5 inches. Okay, that's like the length of my thumb.
Uh,
But why is it moving away? Is that like a bad thing? Should we be worried?
Don't worry, it's not going to disappear anytime soon. This drift is happening because of tidal forces.
Okay.
The same forces that create tides on Earth are also transferring energy to the moon very slowly and pushing it into a slightly higher orbit.
So billions of years ago, the moon must have been way closer to the Earth, right?
Absolutely. It would have looked much larger in the sky
Wow.
and had a stronger gravitational pull on the Earth. Imagine the tides back then. They must have been incredible.
Yeah. Okay, but what about the moon's impact on Earth today?
Okay.
I mean, we've talked about tides, but what other influences does it have on our planet?
Well, aside from the tides, it plays a major role in stabilizing Earth's axial tilt.
Oh, right. The tilt that gives us the seasons.
Exactly. Without the moon, Earth's tilt could wobble a lot more.
Oh, wow.
And we would have these crazy climate changes, unpredictable seasons. Like, imagine scorching summers followed by frigid winters.
It'd be total chaos.
It would be total chaos.
So thanks to the moon, we have those lovely, predictable seasons.
Exactly. It's really played a crucial role in creating this stable environment that allows life to thrive.
So we basically owe our existence to the moon.
In a way, yes.
That's incredible. But the moon's orbit is kind of interesting too, right?
It is.
Doesn't it travel around Earth in like a perfect circle?
It would seem that way, but actually no.
Oh,
It travels in an elliptical orbit,
okay. Elliptical.
which means that its distance from Earth is always changing.
Oh, okay.
The closest point is called perigee,
Perigee. Okay.
and the furthest point is called apogee.
Apogee. Okay.
And this difference in distance affects how big the moon looks to us.
So that's... Wait, does this have something to do with those supermoons we hear about?
Yes, a supermoon is when a full moon happens at the same time as perigee.
Oh,
So it looks extra big and bright.
So it's not just an illusion. The moon really is closer during a supermoon.
Exactly. It's really closer.
Okay, that's amazing. So what happens when the moon is at its furthest point? Apogee.
Then we get a micromoon.
A micromoon.
Yeah, it's like the opposite of a supermoon.
So it's a mini moon. Okay, so one more thing about the moon's orbit.
Okay.
Remember how we talked about the Earth's tilt?
Mm-hmm.
Well, the moon's orbit is also tilted.
It is.
About 5 degrees relative to Earth's orbit around the sun, so it's not perfectly aligned with us.
Right.
Does that cause any problems?
Well, it does make things a little more complicated.
Okay.
That tilt is actually why we don't get eclipses every month, because the moon sometimes passes above or below the Earth's shadow because of that tilt.
So it's a cosmic balancing act.
Yeah.
But, okay, before we move on, we have to talk about, like, all those moon myths.
Oh, yeah.
Like, the dark side, which we already debunked.
We did.
But are there any other, like, moon myths that we should tackle?
Oh, absolutely. A big one is that people think that lunar phases are caused by Earth's shadow.
I can actually see how people would think that.
Yeah, but it's really about those angles of sunlight, remember?
Right. Okay, what about the moon's influence on animal behavior and human behavior?
Uh-huh.
Like the whole must be a full moon thing.
Yeah. It's tricky because some animals definitely use the moon for things like navigation and reproduction.
Okay.
But for humans, the evidence is less clear.
So the whole full moon makes people act crazy thing is probably not true.
Probably not. The moon's cultural impact is undeniable.
Right.
But scientifically, the evidence is mixed on whether it actually directly affects human behavior.
Good to know. Okay. Now, let's talk about the moon's formation.
Okay.
Remember that collision we talked about, that Mars-sized object?
Oh, yeah.
Well, that's actually the leading theory for how the moon was formed.
Right.
It's called the giant impact hypothesis.
Mm-hmm.
And it explains why the moon is made up of stuff that's similar to the Earth's outer layers. So the impact would have flung out material.
Right.
And that eventually came together to form the moon.
It's like a cosmic recycling project.
Right. And that's why the moon is less dense than Earth.
Yeah, because it's mostly made up of those lighter materials from the outer layers.
Okay. So I think that's a good place to, pause and just recap why the moon doesn't crash into Earth.
Okay.
I know it's a simple question, but it's kind of mind-bending,
It is. But the basic idea is that the moon is in free fall, but it's also moving sideways.
Right.
That sideways motion is what keeps it in orbit.
So it's falling, but it's also moving forward.
Yeah, it's a delicate balance.
Okay.
And that balance has really shaped our world.
Yeah, it really has. Okay, listeners, we're going to take a quick break, and then we'll be back to explore even more about the moon.
See you soon.
All right. Welcome back, everyone. I don't know about you, but I am still thinking about all that cool stuff we talked about with the moon.
Yeah, it really is amazing.
So much to learn.
Absolutely.
But before we, keep going on our little lunar adventure,
Okay.
I kind of want to circle back to that whole tidal locking thing.
Oh.
Because, okay, so it's the reason why we always see that same side of the moon, right?
Right.
But how did that even happen?
Okay, so it's all about gravity.
Okay.
Over a really, really long time, like billions of years,
Billions. Yeah.
Earth's gravity has been pulling on the moon,
Okay.
and it created this kind of bulge on the side of the moon that faces us.
Wait, so the Earth is like stretching the moon out?
Yeah, in a way you can think of it like that.
Wow. Okay.
And, the moon was rotating at first,
Right.
but this bulge, it created friction,
Right.
and it slowed the moon's rotation down over a very long time.
So it's like a break.
Yeah, like a cosmic break.
Okay, that's cool. And then eventually it just synchronized with the orbit.
Exactly.
Wow. Okay, so that's tidal locking.
That's tidal locking.
But if it's tidally locked, does it even rotate at all?
It's kind of a matter of perspective.
Okay.
From Earth, it looks like it's not rotating.
Right, because we only see one side.
Yeah, exactly. But if you could see the Earth-Moon system from, way out in space,
Okay.
you'd see that the moon is definitely rotating.
So yes, rotating. But
at the same rate that it's orbiting.
it's like dancing with Earth, always turning to keep that same face toward us.
Yeah, that's a great way to put it.
Okay, so this cosmic dance, it's got some other cool consequences too, right? I mean, we
Yeah.
talked about the tides.
Right.
But have you ever thought about, what would Earth be like without a moon at all?
That's a good question.
Yeah, I don't know.
Well, I mean, for one thing, the night sky would be a lot darker.
Oh, yeah.
Right. But there'd be some really big changes, too.
Like what?
Well, remember we talked about the moon stabilizing Earth's axial tilt?
Yeah, for the seasons?
Right. Without the moon, Earth's tilt would be all over the place.
Oh, no.
The climate would be super unpredictable.
Oh, that sounds scary.
It would be, like scorching hot summers and then freezing cold winters, even worse than now.
Wow. The moon really keeps things in check.
Huh. It does. It's really a big reason why life was able to evolve on Earth.
So the moon is kind of responsible for us being here.
In a way, yeah. It's pretty amazing.
It is. Okay, so remember how we said that the moon's drifting away?
Yeah, very slowly.
Right, but that's got to have some consequences too, right? Like way in the future.
It will, but we're talking like billions of years.
Okay, phew, that's a long time.
Right. But eventually our days are going to get longer.
How?
Because as the moon moves further away, it's pulling on Earth a little less, you know?
Okay.
And that will slow Earth's rotation down.
So a day could be like weeks long.
Or even months.
Whoa, that's hard to imagine. And what about the tides? Those will change too.
Yeah, they'll become less extreme.
Okay.
The difference between high tide and low tide won't be as big.
So the moon is moving away and Earth is slowing down.
Yep. That's the universe for you. Always changing.
And what about the tilt? Earth's tilt.
That's hard to say for sure.
Real-
As the moon moves away, the other planets will start to have a bigger effect on Earth's tilt.
Oh.
Especially Jupiter. It has a lot of gravity.
So our seasons could get messed up.
It's possible, yeah.
Wow. The future is wild. Okay, but those changes are happening way in the future, right?
Yeah, don't worry. It's nothing we need to worry about now.
Okay, good. Okay, well, we talked about how the moon physically affects Earth, but what about us, like humans? Has it really shaped our, history and culture?
Oh, absolutely. I mean, think about it. People have been looking up at the moon for, forever.
Yeah.
It's inspired so much art and music and stories.
It's true, every culture has stories about the moon.
Exactly. And practically speaking, the moon was really important for a long time, too.
How so?
Well, people used to use it to keep track of time, you know?
Oh, right, like a calendar.
Exactly. And farmers used it to know when to plant crops.
Oh.
And sailors used it to navigate.
Wow, the moon was like our first GPS system.
Yeah, you could say that. And even today, people are still fascinated by the moon.
Yeah, for sure.
We send robots to explore it,
Right.
and we dream of going back there ourselves one day.
It's crazy to think we've walked on the moon, but there's still so much we don't know.
That's what makes it so exciting. There's always
Yeah.
something new to discover.
Totally. Okay, I want to talk more about those supermoons.
Okay, the big ones.
Yeah. So they happen when the moon is full at the same time it's at perigee.
Exactly, it's closest to Earth.
So it's like a supersized moon. What about when it's at the furthest point, apogee?
Then we get a micromoon.
The micromoon, like the little brother of the supermoon.
Right. It looks a little smaller in the sky.
It's like the shy one that doesn't want all the attention.
Yeah, I like that.
Yeah.
But it's still a cool part of the lunar cycle.
Yeah, for sure. It's amazing that just the distance from Earth can make such a big difference in how we see it.
It is. It's all about perspective, right?
Okay, so we've talked about so much moon stuff.
We have.
From how it formed to the phases, the tides, even myths about it.
But, what does it all mean? What's the moon's, overall significance? Why is it important?
That's a big question. But I think it's important to remember that the moon has shaped our planet, you know?
Yeah.
It affects the tides, the climate, even the length of our days.
Wow. It's easy to forget how much it does.
It's true. And think about all those stories and myths and art inspired by the moon in every culture.
Right. It's touched every human who's ever lived, in a way.
Exactly. It's been part of our lives for as long as we've been around.
And it's still drifting away, slowly.
It is.
Wow. It really makes you think, something so far away can have such a big impact on us.
It's true. And it leaves us with a lot to wonder about, like what will happen as it keeps moving away.
Yeah. And will we ever go back to the moon?
Who knows? But I think the moon will always be there, inspiring us and making us ask questions about the universe.
Yeah, it's pretty amazing. Okay, we're going to take another quick break, and then we'll wrap up our moon exploration. Welcome back to our lunar adventure. We've covered so much ground already, from the moon's formation to its impact on Earth, even its place in human culture.
It's been a wild ride.
It has. But there's one more thing I want to touch on before we wrap things up.
Okay, good.
So we've talked about how the moon is slowly drifting away from Earth.
Right.
But I'm wondering about the long-term implications of that. If it's moving further away, does that mean its influence on Earth will, gradually decrease?
That's a really good question. And the answer is, it's complicated. I mean, the short answer is yes.
Okay,
The moon's gravity will have less of an effect on Earth as it moves further away.
right.
But these changes happen over billions of years.
Okay, so nothing to worry about in our lifetime.
Definitely not. But it is interesting to think about.
It is. So what kind of changes can we expect? Like way, way in the future?
Well, one of the most obvious changes would be to the tides. They'll become less extreme as the moon's gravity weakens.
So like smaller difference between high tide and low tide.
Exactly.
Okay, interesting. What else?
Earth's rotation will also be affected.
Oh, right, because the moon's gravity is kind of tugging on us.
Exactly. As that tug weakens, Earth's rotation will slow down.
So our days will get longer.
Much longer, eventually.
Wait, how much longer are we talking?
Well, over billions of years, a day on Earth could last for weeks, even months.
Whoa, that's mind-blowing. Weeks or months, I can't even imagine.
It's hard to wrap your head around, for sure, but it's a natural consequence of the laws of physics.
Well, so as the moon moves away, Earth slows down.
Yep, a cosmic trade-off.
Wow. Okay, what about Earth's tilt? Will that be affected too?
That's the big question mark. The moon's gravity helps keep our tilt stable right now,
Right.
but as it moves away, Earth's tilt could become less stable.
Oh, no. So our seasons could change.
It's possible, yeah. The other planets, especially Jupiter, would start to have a bigger influence.
So the future of Earth's climate is a bit uncertain.
A bit, yeah. But it's all happening over incredibly long timescales, so it's not something we need to lose sleep over.
That's good to hear. Okay, well, we've really explored a lot about the moon in this deep dive.
We have.
From its formation to its phases, its impact on Earth, its influence on human culture.
It's been quite a journey.
It really has. And I think we've both learned a lot along the way.
I know I have.
Me too. And I hope our listeners have as well.
Definitely. It's a reminder that there's always more to learn about the universe, even about something as familiar as the moon.
Exactly. So keep looking up, keep asking questions, and never stop exploring the wonders of the cosmos. Thanks for joining us on this lunar adventure.
Thanks for having me.
And until next time, keep those minds curious and those eyes on the stars.